clear, guys? Yes. Now let's see the next problem. You measure two quantities as A is equal to 1 plus or minus 0.2 whole meter, B is equal to 2 plus or minus 0.2 whole meter. Find the resultant if resultant Z is equal to root of A into B. Root of A into B. Yes. So here in this question you are provided with two values, isn't it? You are provided with two values and you are asked to find the resultant. You are asked to find the resultant if resultant Z is equal to root A into B. So since you are asked to find resultant, here you are not asked to find absolute error of resultant, or here you are not asked to find the actual value of resultant, you are asked to find the resultant. So the resultant value consists of, as I told earlier, the resultant value consists of two components. The first one is the actual value. And the second one is the absolute error. Is it clear, guys? So in this question you have to find the actual value as well as the absolute error in the resultant. Yes. Now it is given Z is equal to root A into B. Z is equal to root A into B. So we can calculate the actual value. By simply substituting the actual values of A and B. That is 1 into 2 root 2. Is it clear? Actual value of A and B. I just substituted the actual values of A and B, that is 1 and 2. So I got the value of Z as root 2. The actual value of the resultant is nothing but root 2. Is it clear? Yes. Now we have to find the value of del Z, or now we have to find the absolute error, maximum possible error in the resultant. So how do we find it? It is given Z is equal to A plus B. It is given Z is not A plus B, A into B, root of A into B. We can otherwise write this root AB as AB the whole power half, isn't it? We can otherwise write this root AB as AB the whole power half. Yes. We know A into B the whole power m. A into B the whole power m is equal to A power m into B power m, isn't it? Yes, these are basic maths. A into B the whole power m is equal to A power m into B power m. Also we have A by B the whole power m is equal to A power m divided by B power m. Is it clear? So by applying this concept, or by applying this rule here, you will get A B the whole power half is equal to A power half into B power half. Is it clear? Thus we got Z is equal to A power half into B power half. Here two operations are involved, isn't it? Here two operations are involved. One is power and the other one is multiplication. Here two operations are involved. One is power. We are finding the power of the measure of the physical quantity, as well as we are multiplying two physical quantities. Is it clear? Yes. So we know when power and multiplication is involved, first we have to consider the power, isn't it? We know when both power and multiplication is involved, first we have to consider the power. So here I am going to consider the terms having power. So what is the relative error? Of the physical quantity A? half into del A by A, isn't it? Half into del A by A. Again, what is the relative error of the physical quantity B? That is equal to half into del B by B. Half into del B by B. Here we are multiplying, here we are multiplying these two physical quantities to get the resultant. So when we are multiplying two physical quantities, we know the relative error of resultant, is connected to or is equal to the sum of the relative errors of individual measurements. So we can say del z divided by z is equal to relative error in the physical quantity A, plus relative error in the physical quantity B, isn't it? Yes. So what is the relative error in physical quantity A? Half into del A by A. How do we got this value? Half into del A into A. When we are finding the power of a physical quantity, the relative error of that physical quantity is nothing but we multiply the power value with the relative error of the measurement, with the relative error of the physical quantity. So half into del A by A plus half into del B by B. Half into del B by B. Is it clear, guys, up to this? Now we can substitute the value, or otherwise we can take this half common outside. Half is there in both the terms, so we can take this half common outside. We know del A is equal to 0.2 divided by 1 plus del B is equal to again 0.2 divided by 2. Is it clear? So thus we get half into 0.2 plus 0.1. Thus we get half into 0.2. Half into 0.2 plus 0.1. So we will get 0.3 by 2. 0.3 by 2. That is equal to 0.15. 0.15. So we found the actual value as root 2. We found the actual value as root 2, and 0.15 is not absolute error, but it is the relative error of the resultant. 0.15 is not absolute error of the resultant, but it is the relative error of the resultant. So how do you find absolute error from the relative error of a value or of a measurement? We know del z is equal to z into relative error, isn't it? Z into relative error. Already we have discussed about these concepts. Yes. So what is the value of del z? Del z is 1.414. Root 2 is equal to 1.414 into 0.15. Thus we get the value. Let me do this operation in calci. 0.15 into 1.414, that is equal to 0.2121. Yes. Thus we got the actual value. Of resultant root 2, and thus we got the absolute error of the resultant del z. Is it clear? 0.2121. So we can say the resultant z is equal to I am rubbing off all these. Okay. Yes, we can say the resultant is nothing but 1.414 plus or minus 0.2121. 0.2121. Is it clear, guys? Yes. Okay. Now the next question. An experiment measures quantities A, B and C. Okay. X is calculated as AB square divided by C cube. So, what is the maximum percentage error in X if percentage error in A is equal to 1%, B is equal to 3% and C is equal to 2%, and C is equal to 2%. Okay. So here you are provided with three values. Here you are usually in previous questions you were provided with measurements, isn't it? In all of the previous questions that we discussed, you were provided with measurements, but here you are provided with percentage errors. Directly, and you are asked to find the percentage error. You are asked to find the maximum percentage error in X. So, what is the maximum percentage error in X? We know relative error in X. Here the operations we are performing here it is also given, X is equal to AB square by C cube. Isn't it? X is equal to AB square by C cube. It is also given X is equal to AB square by C cube. Here three operations are involved. One is power, one is multiplication and one is division. In all of these three operations, we consider relative error, isn't it? The relative error of the resultant is connected to, or we can say it depends on the relative error of individual measurements, because the operations involved here is not addition or subtraction, but the operations involved here are multiplication, division and power. So, how do you find the relative error? In the resultant? Yes, you have to simply add up the relative errors in individual measurements. So here you are asked to find the percentage error in the resultant. So what is percentage error? Relative error expressed in percentage is known as percentage error. So we can say relative error in A. Let us assume relative error in A. For the time being, let's assume relative error in A as del A by A, and relative error in B as del B by B, and relative error in C as del C by C for the time being. Yes, after explaining this, yes, we will find the relative error in each term. Now, here you are asked to find the percentage error, isn't it? So what you have to do? You have to multiply each of the relative errors into 100. So actually what is this? Del A by A into 100, del B by B into 100, or del C by C into 100 is what? It is nothing but the percentage error. It is nothing but the percentage error in the physical quantity, or in the measurement of physical quantity A, percentage error in the measurement of physical quantity B, and percentage error in the measurement of physical quantity C. Is it clear? Yes. So now, and in the question also you are provided with the percentage errors of A, B and C, isn't it? Yes. Now let's find what is the relative error. What is the relative error in individual measurements? Relative error in A. Here we have three terms. And first we can say AB square divided by C cube is in X by Y form. That is, we are dividing AB square by C. So first I am going to consider, here we have three terms having power value. So first I am going to consider individual terms A, B and C. So first I am going to find the relative error in A, that is A by A. Next I am going to find the relative error in B, that is 2 into del B by B. Again I am going to find the relative error in C, that is 3 into del C by C. Is it clear guys? Del C by C. Now Now I am going to consider the numerator alone. I am going to consider the numerator alone. Here we are multiplying two physical quantities. Here we are multiplying physical quantities A and B. So how do you find the relative error? How do you find the relative error of the resultant? Simply add up. You have to simply add up the relative errors in individual measurement. Now I am going to consider this whole term. So how do you find the relative error? You have to simply add up the relative error of numerator and the relative error of denominator. So what is the relative error of numerator? Relative error of numerator is I have written in this bracket. And what is the relative error of denominator? That is 3 into del C divided by C. So I am adding these two relative error. Is it clear? Yes. Now instead of providing measurements, here you are provided with percentage errors. So we can multiply all these terms. So you can multiply all these terms by 100. So del A by A into 100 plus 2 into del B by B into 100 plus 3 into del C by C into 100. So yes, here you are given del A by A into 100, the percentage error of physical quantity A, the percentage error of physical quantity B, and the percentage error of physical quantity C. So here you have to substitute the values directly. You have to substitute the values for del A by A into 100, that is 1%, and del B by B into 100, that is 3%. Del C by C into 100, that is 2%. So what we will get? 1% plus 2 into 3% plus 3 into 2%. Is it clear? Yes. Here you have to remember one point. Here you are given the percentage error in A, B and C. And this particular term, that is del A by A into 100 or del 2 into del B by B into 100 is the percentage error of B square. Is it clear, guys? Here why we are using, yes, here why we are substituting 3% only for del B by B into 100, because you are given the percentage error in B, but 2 into del B by B into 100 is the percentage error in B square and not B. Similarly in the case of C, del C, 3 into del C by C is the relative error in C cube and not in C. And here del A by A into 100, here we have power of A as 1, isn't it? Here you have power of A as 1, so we can say the percentage error of A and the percentage error of A is 1 and the same, isn't it? Yes. So thus we get 1 into 6 plus 6, that is equal to 13%. So what is the maximum percentage error in the resultant X? It is nothing but 13%. Is it clear? Yes. So in examinations they may ask question in multiple forms. Yes, but the concept is one and the same always. Once the concept is clear, once the concept is clear, and once you learn or once you understand how to apply these concepts properly, yes, you can easily solve these types of questions. Yes. Because we have discussed everything in detail, isn't it? Yes. We have discussed combination of errors. We have discussed 5 cases of combination of errors, and we have also discussed when more than one operations are involved, how do errors get combined. Here if suppose you are given x is equal to, in the question you are given x is equal to AB square by C cube. If suppose it is given A plus B square divided by C cube. If suppose it is given, a plus b square divided by c cube. So how do you find the maximum possible error? How do you find the maximum possible error or percentage error, whatever it may be in the resultant? So here we have two physical quantities. Here first I am going to consider the whole term. Here I am having two physical quantities, that is a plus b the whole square and c cube. So here again I am going to consider this numerator alone. Now I am going to consider numerator alone. Then I am going to consider denominator alone. Okay, yes. So when I here I can see that I have individual terms. I have individual terms having powers. And then we are adding those two terms or adding those two physical quantities. So how can you find the relative error? How can you find the relative error in individual terms having power? The relative error in A is nothing but del A by A. The relative error in B is nothing but 2 into del B by B. 2 into del B by B. Why we are finding out relative error? Because we have terms involving powers. Here we have terms involving power. So if we have terms having power, then we have to consider the relative error. Is it clear? Yes. Now in the question, in your given question, it was given multiplication, isn't it? In your question you are given multiplication, but now it is addition. When we are adding two physical quantities, yes, we have to consider the absolute errors of individual measurement, because the absolute error or simply the maximum possible error is directly related to the absolute error of individual measurement. So for finding the absolute error of numerator, how do you find the absolute error of numerator? You have to simply add up the absolute error in individual measurement A and B square. Is it clear? Yes. And the value or the type of error that we have found out, is not absolute error, but it is relative error. The type of error that we have found out here is not actually absolute error, but it is relative error. So here we have to find absolute error from these relative error values. So how do you find absolute error from relative error values? We know relative error is equal to absolute error divided by actual value. So what is the value of absolute error? We can say relative error into actual value. Is it clear, guys? So absolute error is equal to A into del A by A, plus 2 into B square into del B by B. Is it clear? 2 into B square into del B by B. Yes. Now both of these A will get cancelled, so we will get del A plus, and 1B will cancel, 2B into del B. So thus we got the absolute error of numerator. Is it clear? So del A plus 2 into B plus 2B into del B is the absolute error of numerator. Now let us consider the denominator alone. In denominator we have power. So since we have power, we have to find the relative error. So we got 3 into del C by C. Is it clear up to this? Yes. Now I am going to consider this whole term, that is both numerator and denominator, and I observed that we are dividing two physical quantities there. So when we are dividing two physical quantities there, we have to consider the relative error of measurements. There we have to consider the relative error of physical quantities, because the relative error of the resultant is connected to the relative errors of physical quantities. So here I got the value, or I can say I got the value of relative error of denominator. C cube is equal to 3 into del C by C. Now I need to find the relative error in the numerator. I need to find the relative error in the numerator. Here actually I found the absolute error in numerator. Here actually I found the absolute error in numerator. Now for finding the relative error in the resultant. Now for finding the relative error in the main resultant. Yes, I have to find the relative error of numerator. So here I got the value of absolute error of numerator. From this I have to find the relative error. How do we find relative error from absolute error? We know relative error is equal to absolute error divided by actual value. So here I have relative error is equal to the value of absolute error is del A to B del B divided by what is actual value is equal to? Actual value is equal to A plus B the whole A plus B square. Actual value is equal to A plus B square. Is it clear? Thus I got the relative error. Thus I got the relative error of numerator and I got the relative error of denominator. Now we have to find the relative error, whole relative error of the main resultant. Del x by x is equal to relative error in numerator, that is del A plus 2B into del B divided by A plus B square plus relative error in C denominator, that is 3 into del C by C. Is it clear guys how to find the relative error? How to find relative error or percentage error or absolute error when more than one operations are involved? Yes. Yes. Next question. It is given period of oscillation of a simple pendulum T is equal to 2 pi root L by G, where L plus del L is equal to 20 meter plus 0.1 meter. T plus or minus del T is equal to 90 seconds plus 1 second. What is the maximum percentage error in G? Percentage error in G. So this is the last question under this topic. Yes. So here you are given an equation for the time period of oscillation. T is equal to 2 pi root L by G. Here T is time period of oscillation, L is length of the pendulum and G is acceleration due to gravity. We will discuss everything about simple pendulum oscillation in some other chapter. Now for the time being, just understand T is time period, L is the length of the pendulum and G is the acceleration due to gravity. Here you are asked to find, here even though you are given equation for time period, you are asked to find the maximum percentage error in G, that is acceleration due to gravity. Values provided, the length of the simple pendulum and the time period. So for finding the maximum possible error or finding the maximum percentage error in G, first we have to find how G depends on these two quantities T and L. Isn't it? How G depends on these two quantities T and L. How do we find how G depends on other two quantities T and L? We have to calculate, or we have to, from this given equation, we have to find what is G equal to in the terms of T and L. So we can rearrange this equation. Like we can write this root otherwise as whole power half. Again, we can rearrange this equation as 2 pi into L power half divided by G power half. Is it clear, guys? A by B, the whole power m is equal to A power m divided by B power m. Same concept. Now I got T is equal to 2 pi into L power half divided by G power half. Now I am going to bring this G power half to the left side of the equation, and I am going to bring this T to the right side of the equation. So we can write G power half is equal to 2 into pi into L power half divided by T. Is it clear? Here you got G power half is equal to, but actually I want to find what is G is equal to. I want to find what is G is equal to. How can I find G is equal to from G power half? I have to simply square the term. I have to simply square both the terms, or square the terms on both sides of the equal sign to find G. So we know G power half the whole square is equal to G, and here you will get 2 square into pi square into L divided by T square. Since here you are asked to find the maximum percentage error, there is no need of considering constants. If you are asked to find the actual measurement of, if you are asked to find the measurement of G, yes, then you have to consider these two constants, and you have to find the absolute error. You have to find the absolute error in G, and also you have to find the actual value of G. Since here we are asked to find not the measurement of G but the percentage error in G, so there is no need of considering these constant values. Thus I got G is equal to L divided by T square. Here I have to find the maximum percentage error in G. So here two operations are involved in this particular equation. Two operations are involved. One we are finding the power of individual terms, and then we are dividing those terms. So in these two operations, when these two operations are involved, yes, we have to consider only relative errors of the measurements. So what is the relative error of del? That is del L by L. What is the relative error of T square? 2 into del T by T. How do you find the relative error in G? Del G by G is equal to simply adding up those two relative errors of individual measurements. Is it clear up to this? Now it's very easy. Now the remaining steps are very easy. Here we have to simply substitute the values. Substitute the values for del L and L and del T and T. So what is del L? Del L is equal to 0.1 divided by 20. Plus what is del T? Del T is equal to 1 divided by T is equal to 90. So once you solve this, you will get the answer, and you have to find what is the relative error in percentage. Hmm. 0.1 divided by 20, that is equal to 0.005 plus 2 divided by 90, that is equal to 0.022. So that is equal to 0.005 plus 0.022, that is equal to 0.027. 0.027 is the relative error in G, but here I am asked to find the percentage error, so I have to multiply it with 100, so I will get 2.7%. I will get 2.7%. Is it clear, guys? If you are asked to find the measurement of G, how do you find? Yes, since we are asked to find the maximum percentage error, yes, I omitted these constant values. But if you are asked to find the actual measurement, yes, then you have to consider these constants also, and you have to multiply. These constant values. Is it clear? Yes. So yes, that's all about the topic error. Under the topic error, yes, we discussed so many subtopics like accuracy, precision, error, some problems on these three topics. Then we discussed different types of errors. Then we discussed absolute, relative and percentage error and problems on them. Again, we discussed a very important topic, that is combination of error, under which we had 5 cases: addition, subtraction, multiplication, division and power. And finally we discussed and again also we discussed how errors get combined when more than one operations are involved. And finally we discussed some problems on combination of errors. Yes, I hope everything is clear to you. If you have any doubts, yes, please feel free to ask in the comment section. Yes, so let's wind up this error session. So let's meet in the next session with some other topic. Until then, bye bye.